All right, let's talk about something we see almost every single day, but maybe don't think about too much. You look up, and there they are. Clouds. We're going to get into the science of how these amazing things are actually formed.
I mean, who hasn't done this, right? You're just lying on the grass, watching these giant, fluffy shapes float by, and you start to wonder, how in the world do they get there? What are they even made of? Well, today, we're going to find out.
Okay, so before we can get into the how, we kind of need to nail down the what. What exactly is a cloud? Let's start right there, with the absolute basics.
So it's really easy to think of them as just cotton balls in the sky, right? But here's the deal. A cloud is actually a gigantic collection of billions and billions of teeny tiny water drops or little ice crystals. They're all just floating together, suspended up there in the atmosphere. So yeah, it's pretty much just water hanging out in the sky.
But wait a second. If clouds are just water, where does all that water come from? I mean, there isn't some giant faucet in the sky, right? Well, this leads us to a key ingredient, an invisible one that's actually all around us, all the time.
Believe it or not, the main ingredient for every single cloud is in the air you're breathing right now. Yep, even on a perfectly clear blue sky day. It's called water vapor. It's just water that's turned into a gas, and our eyes can't see it at all.
And where is all this invisible vapor hanging out? Well, it's in our atmosphere. You can think of the atmosphere as this huge protective blanket of gases that surrounds the whole planet. It's the stage where all of our weather, and I mean all of it, including clouds, takes place.
So the next logical question is, how does the water get into the atmosphere to begin with? It's a process I'm sure you've heard of, evaporation. It's pretty simple, really. The sun shines down, it heats up the water in oceans, lakes, you name it, and that liquid water turns into that invisible gas, that vapor, and rises up into the air.
Okay, quick recap. We've got our ingredients. Invisible water vapor just chilling in the atmosphere. So now, let's get to the fun part. What's the recipe? How do we go from invisible gas to those big, beautiful clouds we see floating by?
The whole process kicks off with one really critical step. The air has to get cooler. And how does that happen? Well, usually it's because warm, moist air starts to rise. And as you know, the higher you go up in the atmosphere, the colder it gets.
Here's a great way to think about it. Imagine warm air is like a big, thirsty sponge that can soak up and hold a ton of that water vapor. But as that air rises and gets colder, it's like that sponge is getting squeezed. It just can't hold on to all that moisture anymore. Eventually, it hits a point where it's completely full, or what scientists call saturated.
And this is where the magic happens. It's a process called condensation. That invisible water vapor starts changing back into actual, tiny liquid water droplets. But they can't just float there by themselves. They need something to grab onto. So these little droplets form around tiny, microscopic particles that are always in the air. We're talking specks of dust, pollen, even salt. And when billions upon billions of these droplets get together and cluster up, poof, you have a cloud. A visible cloud is born.
So that's the science behind it. But you know what? Seeing is believing. And what's super cool is that you can actually recreate this whole process from a saturated atmosphere all the way to rain with just a few things you've probably got lying around the house. So let's do it. Let's make our own cloud in a jar.
You really don't need much for this. Just find a clear jar, grab some water, some shaving cream, that's going to be our cloud, a little blue food coloring for the rain, and a dropper if you have one.
All right, you got everything? Let's do this. First, take your jar and fill it up about 3/4 of the way with water. That's going to be our atmosphere. Then, put a nice, thick, fluffy layer of shaving cream right on top. There's your cloud. Okay, now, in a little cup or something, mix that blue food coloring with a tiny bit of water. Now for the fun part. Take your dropper and start adding that blue water drop by drop right onto your shaving cream cloud.
Just keep adding those blue drops. You'll start to see that shaving cream cloud get heavier and heavier with the blue water. See? It's getting saturated, just like a real cloud. And then, watch. Once it just can't hold another single drop, it starts to rain. You've got blue rain falling right there in your jar. That is exactly what's happening on a massive scale up in the sky.
How cool is that? But clouds are way more than just a neat science experiment or pretty things to look at. So let's kind of zoom out now and take a look at the bigger picture, because you might be surprised at just how important they are for, well, the entire planet.
For starters, you can think of clouds as Earth's personal thermostat. It's amazing, really.
During the day, those bright white tops reflect a ton of sunlight back into space, which helps keep the planet from getting too hot. But then at night, they do the opposite. They act like a giant blanket, trapping heat that's rising from the ground and keeping things warmer than they would be otherwise.
And their job doesn't stop there. Oh no, clouds are, pretty obviously, the source of all our fresh water. We're talking rain, snow, the whole deal. They also act like a massive global transportation system for energy, moving heat from the warm equator up toward the poles. So yeah, studying them isn't just for fun, it's absolutely essential for understanding our weather and our climate.
So, we've seen how they're made, and we know just how critical they are for, well, pretty much everything, from our day-to-day weather to the stability of the entire planet's climate. Which leaves us with one last really big thought to chew on. If they do all this, what would a world without clouds even look like?